All right, welcome back to another episode of GLM2. So this day, what I've done is sort of taken these three concepts that we've touched on a little bit over the past several weeks and tried to finish them all up in this particular class. So I'm going to talk about these three topics a little bit today. Maybe. All right, so I'm going to start out by talking about research design, and I want to ask for a show of hands, who here is expecting to, at some point, analyze a difference between, say, a treatment group or a control group? Maybe, don't know. Evaluate whether something is working or not working. I got a couple of folks at home, a couple of folks in the room. So eventually, you may come to a point where you're trying to determine whether or not an intervention has an effect or is effective and works for a particular group of people. And so that's where these experimental designs come in. But I'll get there. Eventually, I'll get there. So in general, there's two types of research designs. We have correlational research designs and we have experimental research designs. There are actually a lot more than that, but those are the two basic frameworks. So what's an experimental approach to research design? Well, the goal in an experimental research design is to control or change or manipulate behavior in some way. Individual differences in an experimental approach are considered error. They're nuisance, they're noise, they're things that we deal with, but they aren't the goal. The focus is usually on one single outcome of interest. It could be a few, but it's usually, I'm going to do this and see what happens to this outcome. And another key here is that subjects or people are randomly assigned to conditions. So you're randomly assigned to be in one condition or another. So that's a basic experimental approach. And you will have this overview in a research methods class. So I'm just touching on it. In a correlational approach, you have people that are more often studied in real-world settings. Situational specific effects are often ignored. Those are treated as noise. But we're focused on multiple outcomes, usually not just one, but taking a multivariate approach, measuring a lot of stuff and seeing what happens. And usually we don't have random assignment in these types of courses, these types of designs. It's just what's happening naturally in the world around us. But the key difference that distinguishes a correlational approach from an experimental approach is random assignment of participants to conditions. If we've randomly assigned people to conditions, we have an experiment. If we have not assigned people to conditions, we do not have an experiment. We have a correlational study. Now, just as a quick sort of aside here, you can do some sort of experimental type approaches with correlational type data, but I'm talking in very much generalities here. So just sort of generally, if we have random assignment, then we have an experiment. So both experimental and correlational approaches have advantages and disadvantages. Now, the nice thing about experimental designs is that when we have experimental control, we have better internal validity, but sometimes that it's at the cost to external validity. And by that I mean, if I want to find out if annoying people while they try to do a memory task affects their memory, I can bring them into the lab and annoy them all exactly the same amount. So it's very internally consistent, but it may not generalize to outside of my actual laboratory. It might not work once they're back in the real world. Now with a correlational design, you have weaker internal validity usually, but effects can be larger. You can also have better external validity because people are already existing in their environments you're studying them in the environments where they will continue to be. Now, regardless of which approach you use, we will often measure an effect. So this is starting to think about effect sizes and what is an effect size. And the goal of an experimental research design is to show that your treatment, whatever it is, had some sort of an effect. And how we would define an effect is the difference between what would happen if someone receives a treatment and what would happen if they did not receive the treatment. And there's a difference between what would have happened if they didn't receive it, and what would have happened if they did. And that difference is called the effect. Sometimes you'll see this, what would happen if they did not receive the treatment. They call that a hypothetical counterfactual. Counterfactual meaning opposite of fact, because it didn't actually happen. So if you want to measure the effect of your treatment, it's not enough to just measure people before your treatment and after your treatment. You really have to compare your treatment group to something. So we have to create something called a hypothetical counterfactual, which is what would have happened if they had not received the treatment. So in order to establish a causal inference and establish that the effect that you're looking at was actually caused by the thing that you think it was caused by, we have three things that have to happen. First, the cause has to come first in time. I have to do the thing, do the cause, and then see the effect. Second, the cause has to be related to the effect. And then third, there must be no other plausible alternative explanations for the effect other than the cause. And so in the next couple of slides, I'm going to walk through examples of how that plays out when we're designing studies and looking at results of studies. So the first two are a little bit easier, but the third one is more difficult because because you have to think about it quite a lot because it comes up in lots of different ways. So you can ensure that the potential cause is due to the effect. The effect is due to your cause through your research design process. So if you have a research design and you attempt to maximize the variance that's systematic, meaning the differences between the two groups that you impose, minimizing error, and then controlling for other sources of variance. Those are the three big things we want to do as this part. How can we control for sources of variance? Well, we can eliminate them by choosing very homogeneous subjects. Everyone is very similar to one another, say everyone taking intro stats. Those are all very similar people. That, however, that's nice because you have more homogeneity, which means more consistent effects, but you're limited in your generalizability. If you use only students from an intro statistics course at a college or university, your results really only generalize to people at a college and university level. Controlling for all sources of extraneous variance through random assignment allows you to control for all sorts of extraneous potential random effects that could be related to the response to your treatment. And if I have randomly assigned people, then they're equated on expectation, and then I'm able to to make some more causal claims. And then lastly, if you know there is something that might affect how people respond to your treatment, you can include that potential source of variance as a variable in your analysis, as a covariate in your analysis. So I'm just going to go through one quick example here. And so let's pretend that we're going to try to predict how much people use the internet from how old they are and how educated they are. Here I have a treatment and a potential cause, which is education. I think that how educated they are is the actual cause of how much they're using the internet. My design here is a survey response. It's all correlational. The outcome is how much they're using the internet in hours per day. And the research question that I could ask from this is, does education cause internet use after controlling for the effects of age? So thinking about how that question could break down following our 3 points, Our analysis we would use would be a GLM predicting internet use from education and age. And then the research question, or the first part of that, is whether we have temporal precedence. So does education precede use of the internet? And I would argue that probably it doesn't. People who are getting a degree or in the process of getting a degree may or may not have already been using the internet. So I can't really establish this as coming first. Is it related? Are the two things related? They might be. Are there alternative explanations? And remember, the three alternative explanations to look for are, do we have homogeneous subjects? No, we don't. We have a very wide range of subjects. Did we use random assignment? No, we did not. Did we use covariates? We used age as a covariate. But was that enough to rule out alternative explanations? Probably not. There could be many other alternative explanations for why these two things are related besides just education. So we can't make that causal claim. I feel like I went much more causal with this than I really wanted to. So what I wanted you to do next is to sort of think about other alternative explanations for any relations between education and internet use we might find. So just take a second and think about if we find a correlation between how educated someone is and how much they use the internet, why might that be? That's not because they're educated. If anybody feels very clever, go ahead and spit one out. Oh, somebody said something here. Wealth, yeah. So if somebody is wealthier, they're more likely to have access to the internet and more likely to be more educated. That's a really good third variable that could be causing both of these things. Yeah, so time, if you have a job or whatever job that you have, you may not be able to go online as often. So people who are well educated might be more likely to have a particular type of job that lets them mess about on the internet all day. Yes, and Kimiko says the same thing, types of work, same idea. The different types of work will have different ways, times they could spend on the internet. What about the opposite? Oh, go ahead. Did you have one?
I was thinking more so when they got their education.
When they got their education? Mm-hmm.
So depending on how far back, they're not going to be using the internet for any part of it. And so why would you perhaps continue to? So it could have been when that degree was given.
So that might be a really important thing to consider is when did you get your degree? Not just how old you are, but when you got the degree, because that could play into weaken or strengthen the relationship between education and internet use. It also could go the other way, right? People who use the internet more might be more likely to then go and get higher degrees. So there's all kinds of difficult potential relations underpinning just this one correlation. So if you're going to try to make a causal claim or a claim about a direction of a relation, it's important to consider these three aspects. I'm going to actually not do any more of these because I feel like that's outside of the scope of really what this class is. But if you would like to walk through another example, I have one here that's for an actual randomized control trial treatment. And so then what I've done here is put them together into a little organizational chart to look at the research question type. So if you have a descriptive sort of question of what's happening now or how many people do this thing, you can test, these are the 3 causality requirements. Does it precede it? Is it related? Are there alternative explanations? And then here are appropriate research designs for this particular type of question. So if you are looking at these things, this is a little guide that you can use to follow along. Okay, so in any study that you have designed for causal inference, and within the education research, it's typically something like, I think that this new curriculum is going to work better than this old curriculum. Or I think if I can just get teachers to do this thing, then the kids will be better off at this other thing. So that's one thing that happens a lot in education research. Using control, using manipulation, using comparison, you can use all of those things to meet the needs of causality. You can isolate the cause by manipulating just one X, only one X, meaning maybe give the intervention to one group and not to the other group. And that allows you to compare what happens to Y without X with what happens to Y when you have X. So I wanted to give you a little bit of an example from a paper from 1991. And the research question here is, what are the effects of print exposure? So we're looking at kids in 4th, 5th, and 6th grade. They measured some alternative potential explanations for the relations between print exposure and I think they're looking at reading as their outcomes, because they want to see print exposure on reading. If I just read to these kids more, are they going to be better readers? So they've taken all of these assessments at one time point, either in 4th, 5th, or 6th grade, and they're using a correlational, a GLM, a regression analysis. And here are their results. They have a correlation table here. The way that they measured print exposure is actually kind of cool. What they did is something called a title recognition test. And the idea is they gave kids names of like 25 or 30 books. Some of them were real and some of them were fake. And they asked them to pick the real ones that you have read. And so they get that, an index of how much exposure to print they have in this way. So these are all different things that are related. We have some IQ tests. They have phonological coding, which is like all of these are sort of components that underpin reading. So what they're looking at here is that this title recognition test is significantly correlated with all this other stuff. So they're asserting here then that they're trying to test the hypothesis that print exposure has some sort of effect on kids. Whoops. And so here's the next part that they do in their output. You see they've done a regression analysis in multiple steps. So at first they're putting in age as a control variable, and you can see that you get an R squared just for age. And this is the significance test of that R squared change. And then they put in the Raven progressive matrices, which is an IQ test, and then they're seeing how much more of the variance is explained. How much more of the variance is explained once you use this phonological awareness measure. And then print exposure is their key variable that they were really interested in. And they do the same thing. So they predict both vocabulary and they predict spelling using multiple steps. And what they did is they put print exposure in the very last step to see how much additional variance is being explained by this one last measure. So what they've done here is they've ruled out alternative explanations that any relations between print exposure and vocabulary or between print exposure and spelling would just be related to how old they are, like just maturation, to IQ, or to this word reading assessment. I liked this example because I feel like it ties in with what we did last week, looking at how people represent their research questions and test their research questions using these general linear models. So, to break it down here, they wanted to make a causal claim that print exposure has a unique causal effect on vocabulary and on spelling. Does the cause precede the effect? The potential cause precede the effect? A potential cause is print exposure. So theoretically, yes. Although they are tested at the same time, theoretically, it's like what you had been exposed to in the past is what's being assessed by this. That one's a stretch, I think. Are they related? Is the cause related to the effect? So these tell me that yes, the cause is related to the effect, so we meet that second point. What about other explanations? Why else might print exposure be related to vocabulary? I'll give you a hint. It's a lot of what you already suggested as good alternative explanations. Anyone have an idea why those two things might be related that's not cause of print exposure? Yeah. Socioeconomic status could be one. Kids who have higher socioeconomic status might be more likely to have a higher vocabulary and might be more likely to read more books. Yeah, that's a good one. Ooh, nice. Parents' education, so parents who are more educated may be more likely to have kids with higher vocabulary and more likely to have more books. That's a good one. We have from Kimiko, she says, greater print exposure may be related to more time with parents reading books, and more time is probably also related to how much they speak with their parents, which could also increase vocabulary.
Looking if it's a bilingual household or not. We're only looking for English.
Yeah, maybe it's a bilingual household. If we're only looking at English, that's not really explaining what might be going on here. Yeah. Interesting. Yeah, so I think you all came up pretty quickly with just a couple of these alternative explanations. So even though print exposure is related, I don't think that we can make the causal claim in this instance. We have not, it does not necessarily cause the outcome that they wanted. So when you're reviewing papers, which will happen very soon if it hasn't happened already, if you see people trying to make causal claims like print exposure causes increases in vocabulary, use this little rubric to think to yourself about what other possible explanations could there be. What is a third variable that might exist that could explain this relation that's not just a cause? Okay. And that is the end of the section on causality.